Alright guys, we are going to review factoring, and here's the handout that we received last week. And we're going to do like a couple of videos. Let's first start out by explaining factoring out the GCF, right, which I hope we all already understand. Factoring out the GCF. So right here we have two terms. What's in common in both terms? Well, there's definitely a multiple of 2, because there's a 2 right here and a 6 right here. So you could pull out the multiple of 2. And there's also x's in common here and here. And the thing is, there's 7 x's here and 2 x's there, so the greatest amount of x's we could pull out from both of them at the same time would be x squared. So the GCF is 2x squared, and if you pull out a 2x squared from here, you'd have a x to the 5th left over, and if you pull out a 2x squared from here, you'd have a negative 3 left over. So let's do a couple of these examples. We already did them in class. Let's do them again right here on the video. So there's a multiple. What multiple is in common in all three terms? Well, there's a 4, a 6, and an 8. If it were a 4, 8, and 12, then you could pull out a 4, a multiple of 4. But in this case, the greatest multiple you could pull out is 2. So we're definitely going to pull out a 2. Bless me, right? A 2. Get it? Okay, that's not funny. Anyway, what would be left? No, I'm sorry, not what would be left. We need to also pull out x's, because there's x's in all terms. So what's the greatest amount of x's we could pull out from all of them? Just a single x. Yeah, there's 5 here, there's 2 here, there's 1 here. The greatest amount of x's we could pull out from all three of them at the same time would be just 1 x. So what would be left on the inside? Well, it's kind of like this. 2x times what will get us back to this first term? Well, in order to get that 4, it's going to be 2, because 2 times 2 gives you 4. And now we need to think, what about the x's? This x times how many x's will get us back to the x to the 5th? Well, that would be x to the 4th, because x times x to the 4th will get you back to the x to the 5th. Anyhow, how about 2x times what will get us this negative 6x squared? Well, 2x times negative 3, the coefficients, 2 times negative 3, will take us back to that negative 6. And how about the x's? X times how many x's will get us to that x squared? Well, that'll be one single x, because x times x is x squared. And last but not least, 2x times what will get us back to this negative 8x? Well, that'll be a negative 4, and that's it, because 2x times negative 4 will get us the negative 8x. If you put an x right here, that would be wrong, because x times x will get you x squared, and that's definitely not an x squared, it's just an x. Moving on to this next one, we're going to pull out the GCF, and if we think about the coefficients, we have a 12, a 6, and an 18. Yes, you could pull out a 2 also, but there's more. It's not the greatest common factor, or in this case, the greatest common multiple when we're thinking about the numbers. So when we're thinking of 12, 6, and 18, 2 will definitely work, but it's not the greatest. 3 will definitely work, but there's still a number greater that's in common in all of them, which would be the number 6. So we're going to pull out the coefficient 6, the multiple of 6. How about x's? Well, you have 12 x's on this first one, 6 on this one, 3 on this one. So you're always going to look for the least one, because that's the greatest amount that you could pull out from all of them, right? Like you can't pull out, you could pull out 12 from here, but you can't pull out 12 from here. So go to the least one, that will be the greatest one that you could pull out simultaneously from all of them. So let's pull out x to the 3rd. So your GCF is 6x to the 3rd. So what would be left over on the inside of the parentheses if you did pull out this GCF of 6x to the 3rd? Well, think about it. 6x to the 3rd times what value will give us this first term? Well, with regards to the 6 becoming a 12, that's definitely going to be a 2. Okay, now how about x's? X to the 3rd times how many x's will get us back to the x to the 12th? Remember, when you're multiplying, you're really adding exponents. So that would be an x to the 9th. So that first term is 2x to the 9th. Let's move on to the middle term. 6x to the 3rd times what value will get us the negative 6x to the 6th? Well, with regards to the 6 times what will get us a minus 6? That will be a minus 1. And now let's think about the x's. X to the 3rd times how many x's will get us back to the x to the 6th. Again, remember, when you're multiplying, you're really adding those exponents. So that would be x to the 3rd also. X to the 3rd times x to the 3rd is x to the 6th. And now for the last term, this whole thing, 6x to the 3rd times what will get you back to the negative 18x to the 3rd. That will be a negative 3 starting out, because the 6 times negative 3 will get us that negative 18. And how about x's? Well, how many x's are up here? X to the 3rd. We already have x to the 3rd here. So x to the 3rd times what will get us x to the 3rd? You don't need to put anything, right? That's it. And that's your final factored form. Now, of course, you're always supposed to try and continue factoring on the inside, like this. Now, the thing is, right here, you can't factor any further. Sometimes you may have, if we move on to this next section, factoring ax squared plus bx plus c, where a equals 1, that means that there is no number out here in front. So like this quadratic trinomial, it is factorable because there's no number out here in the front, and all you got to do is think what times what is the last one that if you add together is the middle one. So if you had something like this, a quadratic trinomial like x squared plus something x plus something, or minus, like up here, if I had an x squared plus something x plus something, then I could try to continue factoring by putting the parentheses like this, but we know that that's not the case right here. That's as far as we could go, because we have an x to the 9th and an x to the 3rd. So in this case right here, we did factor out a GCF of 2x. There's a 2 here, a 2 there, a 2 there. Pull out the 2, and there's also x's in all of them, so we pull out 2x. This is what's left over. Now on the inside, you could continue factoring, and that's why we put these parentheses here. And the way to do it is to simply think what times what is the c value that if you add together is the b value. So how could we get negative 20? You could make a list. Negative 1 times 20, negative 2 times 10, negative 3, no, negative 4 times 5, and that's about it. Those are all the possible ways of multiplying numbers to get negative 20. Now, which pair of numbers will combine together to give you the middle value, which happens to be 1, positive 1 in this case? Well, if we were to add these guys, you get 19, right? Negative 1 plus 20 is 19. If you add these guys, you get 8, and obviously this middle number is not 8. If you add these guys, yeah, you do get positive 1. So we know that this is the correct combo right here. And what do we do with these? You simply take that negative 4, put it right there, take the 5, put it right there, and there's your answer in factored form. Okay? So that's the way to do it. We'll make another video with the next section, picking up from here.